Welcome. This is Richard Pickings of Bridgeside Software. In this tutorial, I'll provide a whirlwind introduction to the PGSuper Bridge Girder design program and how to use PGSuper to design a precast girder in a TxDOT production design environment. PGSuper works like most Windows programs, but it has some unique features. So I'll explain those concepts to help you get started using the program quickly. I'll be using our PGSuper Professional product, but the Texas DOT and Washington State versions work similarly. Let's take a look at the Texas bridge we'll use for the tutorial. You can download detailed plan sheets for the bridge on the web page where you found the tutorial on PGSuper.com. It's a fairly simple two-lane bridge with 34-foot wide deck. The two 100-foot spans are simply supported, as is typical in Texas. A straight horizontal roadway alignment with a 2% crown elevation on both sides. There's a sag vertical curve with a point of intersection near the beginning of the bridge. All piers and abutments are oriented at a 30-degree left skew, and there are 5 TX46 I-Girders at 7-foot spacing. Barriers are TxDOT type T222 on both sides. And to make things a little more interesting, we have a 10-kip light post at the quarter point in span 1 on the left side of the bridge. And we'll assume that the light post load is distributed to the 2 exterior girders. Important thing to understand is that PGSuper is just one of the applications in the BridgeLink software suite. So to run PGSuper, you run BridgeLink from the Windows Start menu. And here is the initial PGSuper or BridgeLink Professional screen when you first start the program. And as you can see, there's no file loaded yet. Before we can get started, we need to configure PGSuper for the Texas Department of Transportation. And another thing to make clear is that PGSuper is not just a Texas or Washington State program. The program is highly configurable, and it can be used for really any agency that uses the AASHTO LRFD bridge design specifications. So now we're going to click on File, Configure Bridge Link. And this will bring up a wizard that allows you to configure the program. On the first screen, you can enter your name and a company. And this information is used in reports generated by the BridgeLink programs. The information is not uploaded to the web, so you don't have to worry about privacy. Click the next button, and we'll be at the Configure PGSuper wizard step. As you can see right now, the program is configured to use the Washington State DOT server. And on that server is several configurations, one for Washington State. And one thing of interest here is the AASHTO standard girders from PCI BDM configuration. This is a very generic AASHTO LRFD setup. So if you're working using PGSuper for a state that doesn't have a custom configuration for it, this is a good place to start. But for today, we're going to go to the Texas server, which actually is in Austin, Texas, and select the TxDOT configuration. Click the next button. We'll go to Configure PG Splice. This is a splice girder design program we're not going to be talking about today. And next, we configure the Texas Optional Girder Analysis program, which is another program we won't be talking about today. And as you can see right now, the program is actually going out to these servers and pulling down the configurations live. What this means is, for instance, Texas DOT, they can make a change to their configuration, and PGSuper, all around the world are automatically updated. Now let's open PGSuper and start defining our bridge. From the BridgeLink menu here, we go to File, New. This brings up the new project dialog with all of the templates for all of the applications in BridgeLink. And there's multiple applications here, but what we're going to deal with today is PGSuper. So you can see PGSuper project templates. And these are the templates created by TxDOT. So for instance, you can see projects organized by girder type of all the different templates that Texas has created. And today we're going to start a template with a TX46 girder because that's the girder for our red mud bridge. I'll double click on the TX46 little icon. This will bring up a dialog that wants us to type in project properties. I'm going to say red mud for the project. There's other information you can type in here. As you can see, the name and company have already been typed in. And all these properties get echoed in reports. Okay, so here we have a template. That's our first start at a template bridge. And the way I like to think about templates are in Microsoft Word, we have letterhead, and you don't have to retype all your name and address and all that stuff every time in a Word document when you're going to write a letter. And that's what the template does for you, except a lot more in the case of PGSuper because there's literally thousands of data elements that are already predefined for you when you start up a new bridge project. And this really helps a couple of things. Helps the Texas DOT folks define their specifications and enforce their specifications, and it makes it much easier for you to start up a bridge. So before I get to editing, let's take a quick look at the PGSuper user interface. As you can see, it's an object-oriented interface, and you can click on different items throughout the interface and edit and modify them. And let's take a look, for instance, at editing a girder. So we'll start here. We can click on girders, both in the plan view and the section view. And you can see the selected girder is highlighted. If you want to bring up the editing for a girder, you can double click on it. You can also click on the little icon here, the pencil girder icon right here, and that will bring up the editing dialog. If I don't have any girders selected, and I click on that, it'll ask me which girder I want to edit, which is kind of handy. And also there's the edit girder from the main menu, which will do the same thing. So I'll go ahead and bring this up. And one thing I want to talk about a little bit is the help in PGSuper. I can click right here on help, and it brings up the help for the program. Okay, this is basically a context sensitive help. So, when you're in that dialog, it brings up help for the girder details dialog. Documentation is really important. We have extensive documentation in the program. And one thing I really encourage all engineers who are going to use the program is to take a look at the technical guide, because this gives all of the methods and details, engineering of how the program works. Very important to understand what a program does before you start using it. First, let's define our roadway alignment. So we go to Edit, Alignment, and that brings up our alignment description dialog. And we're on the horizontal alignment tab. This is a straight roadway, so for the horizontal alignment, all we need is the initial direction. This is in bridge engineering or surveying terms. So we have north 89 degrees, 15 minutes, 22.29 seconds west. We don't have a horizontal curve for our bridge, so we're pretty much just finished here entering our horizontal alignment information. For the profile curve, we do have a curve, a vertical curve. So we're going to need to input the information that describes the profile. Let's start at the initial grade. This is at negative 1.6219%. Again, this is in bridge terms, so it makes it easy to input. So let's go ahead and add a curve. The point of vertical intersection of the curve is at 507 plus 12.85. We have an exit grade on the curve of 2.6968%. And we have a curve that's a simple curve with a constant radius of 785 feet. So we only need to enter L1 here for our curve. As mentioned earlier, our roadway cross section. We have a crown curve, basically, or a crown super elevation with the sloping off at 2% from the center of the bridge or the center alignment point. So we can enter here minus 0.02 degrees. And the sign convention here is from the alignment point. So alignment point 1 up is positive, so we have a negative slope on both sides. And the picture here is real helpful. You can see that we have a crown vertical alignment. One thing to note here is that you can input super elevation transitions by entering stations along the alignment. And for all of the input here for the alignment, we started at station 0. Our bridge is really 10 miles out on this alignment, but it's fine. These are initial conditions, and this is what we want. So we're done here with our alignment description. We can go ahead and click OK. You might notice that the north arrow is now pointing downward. Let our alignments define, we need to locate our bridge along it. If you can notice that pier locations are in station coordinates, and we could directly enter coordinates here on the plan view. But what I prefer to do is to use the bridge description dialog layout tab. So we'll go to Edit Bridge and to the Layout tab. This allows us to change all of our stationings and skews in one place easily. So what I will do is enter the stationing of abutment 1. It is at 507 plus 15. Once I input that, we can see that our span length is negative because it hasn't moved the other piers yet. I could go ahead and type in the other stationing locations for the other 2 piers, or I could use a shortcut here, layout by span lengths. We know that our span lengths are 100 feet, so just enter 100, 100, click OK. And now we can see that it's updated the stationings, and our span lengths are 100 feet. Similarly, I have to do this stationing or the orientation of the piers. So I can type in 30 degrees left. We know that's our skew angle. Or I can use the shortcut orient piers and type in 30 left, and it will fill all pier skews at 30 left. I'll go ahead and click OK. And here's our bridge on the layout anyway. What we have to notice here, though, is we have a 44-foot wide deck, and we're showing 6 girders. That is not what we want. We have a 34-foot wide deck with 5 girders. We'll go ahead and change that. Once again, from Edit Bridge. Shortcut to getting to Edit Bridge is any place on the white space you can double click. That'll bring up this dialog that we've been using before. We can see our girder type is I-beam TX46, same type for all girders. We want to change to 5 girders. We also have the same spacing for all the girders at 7 feet. We can get fancy here and locate the girders along a bridge line or other places, but we have plumb girders cast in place deck. So we're finished here with this input. I'll click OK. And now we look at the view, we can see that our deck is definitely not the width that we wanted. And this is a nice thing about the bridge-centric user interface that PGSuper has. You can see what's going on very quickly. And I can double click right here on the deck. That'll bring up, once again, the bridge description dialog, but now we're on the deck geometry and materials tab. So we have an 8-inch thick deck all the way across out on the overhangs. We also have a overlay for this case. So I'm going to go down here and change to overlay. Our overlay thickness is 2 inches. And Texas has created this template, and they use 140 pounds per square foot for the overlay unit weight. That's already been entered. Since our deck is 34 feet wide, we can define our deck width, 17 feet on either side of the bridge line. Okay, we have bridge line and alignment here with 2 options. In our case, if we go back here to the General tab, we can see that the bridge line offset is 0. So the bridge line and the alignment are a coincidence for our case. I'm going to go ahead and click OK to update the view. And here we have a bridge that looks a lot like what we want. The bridge geometry and layout are starting to look good, but there's a couple more things we need to do. Let's make sure our barrier matches what we want. As you can see, when I hover over items in the user interface, it brings up a tooltip, and this is showing us that our barrier is T222, which is what we want. But let's double click on the barrier and double check. So from the railing system tab, once again, we're in the bridge description dialog. We can see that we have 2 T222 barriers, so this is what we want. If you click on the combo box here, you can also see there's a bunch of barriers that Texas predefines from their standards. I'll go ahead and cancel out of that. So our barrier looks good. I'm going to drag the section cut along here. Once we're in a span, we can see that our girder spacing at 7 feet is what we want. And we're going to focus on girder 2 in span 1 for the rest of our talk here. If I right click on this girder, I can go to view girder to bring up the girder view. And this shows us a profile picture and section of our girder. One thing to note here is that our span lengths aren't 100 feet. Isn't that what we input? That's kind of strange. What's going on here? The mystery here is pretty simple. As we saw before, our piers are laid out at stations along the alignment. And typically, this is at the center line of piers. So we know that girders don't go, butt to butt from pier to pier, and also bearings aren't located typically at the center line of a pier. So the answer to the mystery is connections. Connections are at pier locations. So we can look here back at our plan view, and we can go to Edit Pier to look at a connection. So we'll edit a pier. We'll go ahead and look at Pier 2. And we can see that the connection definition locates where the end of the girder and centerline bearing is with respect to the pier line. That's our mystery. Texas, by default, in their templates, have certain connection definitions that are standard. So these have already been input for us correctly, so we don't have to change the connection dimensions. Another way to look at connections, which is sometimes a little quicker, we can go to Edit Span, and we can look at Span 1. And from this, we can see connections at abutment 1 and connections at pier 2. Kind of makes it a little faster to see and input connection dimensions. One last thing to do before we can start designing our girders is to define our light post loads. As you remember, this is a 10 kip load and it's going to be distributed to the 2 exterior girders on the left side, so girders 1 and 2 here. So we can go here to Loads, Add Point Load, Load Case DC, that's where we want it to go. The event, we want to be the composite section, so final without live load. Span 1, girder 1, that'll be our first location, is at the quarter point, so 0.25. And we have a 5 kick load that we will name light post. Go ahead and click OK. Another way, if you have a lot of loads, a good way to view them is go to Loads and Edit User Defined Loads. This brings up a window that has all of the loads we've defined in the model. As you can see, there's only one now, and we'll go ahead and add another point load. Again, same thing. This one goes to girder 2, 5 kips, and we'll call it light post again. And click OK. So here's our 2 point loads we're using for our model. And let's go ahead and view girder 2 again. So we'll go ahead and view girder. And if we bring up the correct event, which we know is final without live load, we can see our point load. It's handy to be able to visualize things in PGSuper. Okay, now we're done defining our bridge. So let's go ahead and save. It's always a good idea when you use any software. And we're going to call this red mud. Time for girder design. So we're focusing on girder 2 and span 1. PGSuper has an automated design algorithm that can design for flexure and shear, and we'll use the girder designer to design our girder. To do this, we go to Project, Design Girder. We can also click on this little guy with a hard hat, and it comes up. We want to make sure we're designing the correct girder, so girder 2. If you want, you can design multiple girders at a time, but we're just going to do one. We're designing for flexure. We'll have it design our haunch geometry, and we're going to design for minimum concrete strength. Texas uses a standard stirrup layout at the ends of their girders, so we don't want to change that unless we have to, so we'll leave this option unchecked. Go ahead and run the girder design. It takes a few seconds. And here we have the design outcome. And it tells us that the design for the girder was successful. Some useful information that concrete release strength was controlled by flexural stress, compression at the bottom of the girder, and the final strength was controlled by flexural stress and final compression again. So this is a compression controlled design. We also have information about the number of strands and the concrete strengths used, and also the slab offset and assumed excess camber for the haunch design. I'm going to go ahead and allow it to apply the haunch geometry design from this span to all the girders in the entire bridge, and we go ahead and click Accept the Design. Always when you're using PGSuper, you want to run a spec check. PGSuper has a good design algorithm, but it doesn't always create designs that meet all criteria. So we're going to go ahead first and run a spec check report. And I can right click on the girder again, pick spec check report, or I can go up to view reports, spec check report. Two ways. There's always multiple ways to get things done in this program. We want to go to girder 2 and look at the spec checks. First thing when you run a spec check is to look into the table of contents here. This is a handy feature. Another handy feature here is you can find if you need to search, hold full text search in a report. But we're just going to use the table of contents to take us to the specification check summary. And we look at the spec check summary and find that the spec check was successful, which is a good thing. One thing that you want to look at closely, well, if you're an engineer, you want to look at everything, but we want to look at the Haunch geometry that the design algorithm came out with. And it basically gives us our A dimension. Texas calls this the X dimension that defines the Haunch depth at centerline bearings. And also the other checks, as well as the input assumed excess camber. We input 2 inches of excess camber. The program computed you need 1.86 inches, and it's plus or minus a half an inch. So this passed. Another really good report, if you're doing a Texas design, is to look at the Texas girder schedule report. This is unique to them, but it's also a handy report, I think, for any DOT. And we can take a look at this. Has the girder schedule, which gives you a lot of the basic information about the girder design. I'm looking at the wrong girder here, so I need to go to girder 2. Sorry about this. Run the report again. One thing, if you notice in PGSuper, everything happens on demand, right? I didn't click run or anything. I just asked for a report and it gave it to me. So that's handy. It helps you stay focused on your design. Texas has their own Haunch nomenclature. As you can see, the X, Y, and Z dimensions, and that's reflected in this report. So it's a very nice report when you're doing Texas designs. Now we have a good design for girder 2 and span 1, but we have 9 other girders in this model that aren't designed yet, so we aren't finished with girder design yet. Fortunately for this case, we have a pretty regular bridge, so this won't be too hard, but it can be challenging. And I'll go through some of the basic steps you need to follow. So what we're going to do is go ahead and copy the properties of our already designed girder to the rest of the girders. This can be done from this icon here, the copy girder, or we can go to Edit, Copy Girder Properties. This brings up a nice little report that shows us all of the properties in the girder and how they compare with respect to other girders in the bridge. Our from girder, copy from here, is going to be girder 2. We know that. And the report here is telling us that the other girders don't compare. They're not exactly the same. Okay, so we're going to copy it from our girder 2 to all spans, all girders. And we're going to copy all properties. And note that you can select different properties. If you just want to copy, say, pre-stressing, you can do that. But I'll go ahead and copy now. Now our little report here, comparison report, shows us that all of our girders are the same, and we can close. Okay, so let's look at those other girders. Probably the best way, there's several ways to do this. We have a multi-girder spec check summary. This is for everybody girder design. Or we can use this TxDOT girder schedule report that allows us to look at multiple girders at a time. And something I did earlier but didn't talk about, this is the Texas girder schedule report we already have open for girder 2. This one, we can click the edit button here up, and all the reports have this button. And we can look at all of the other girders in the model. So I can go ahead and say select all. OK, and this will bring up a report for all of the girders in the bridge. Let's take a look at our TxDOT girder schedule report for all of the girders in our bridge. As you can see here, the specification check was successful, and this means for all of the girders. So our design worked well. One thing we want to look at in detail a little bit here is the haunch design for the girder. And as you can see, the provided haunch and the required haunch are exactly the same for all the girders in the structure. This isn't always the case, and often you'll have to modify the haunch depth, the A dimension or X dimension at the end of the girder for individual girders or maybe individual piers. And the best way to do that is to go to the Edit Haunch dialog. And this will allow you to select different ways to input Haunch and Camber in PGSuper, but it also allows you to, for instance, put a different A dimension at each end of every girder on the bridge. Again, for this case, it isn't necessary, so we can skip this step. And we can also look at the provided excess camber, and we can see there is some variation between these numbers on the computed excess camber column, and that's pretty normal. You don't expect exactly the same camber in all girders on the structure, but for us that was the case. And one thing's a little surprising maybe is that our light post load didn't make any difference, and that is because Texas does not factor that load when it comes to the camber calculation. And we can look at this by taking a look at the details report. And this is normally what you'll do. Let's go ahead and we'll look back at girder 2 again. The details report is a very long report, and you can filter your way through this by deselecting different chapters in the report. And really what we want to look at here is the camber details. So I'll go ahead and run that report, and we can come down here to the very bottom of the report where it gives a deflection summary. And you can see here that the factor on the user 2 load case, which is where we applied our load, is 0. So that explains why our cambers aren't changed by the light post. One last step in a typical TxDOT design is to print out TxDOT summary reports, the short form. So let's take a look at doing that. So we bring up that report. We have our girder 2, and they normally want you to print out the load rating summary chapter. So we'll go ahead and do that. And we can take a look at the load rating summary, for instance. And we can see that our rating factors are all greater than 1. Surface 3 stress is pretty close to 1, but that's where we want to be for an optimal design. To print out one of these files, one of these reports, we can just go to File, Print. This works like any other Windows program. So we can go to here, brings up the dialog, and we can pick Microsoft Print to PDF is a pretty good choice for a PDF viewer. And then from here we click print and select the file where we want the PDF file to go to. And that's as far as I'll go on the details with that. This is Richard Pickings, wishing you happy bridge designing.